In this demo, we'll see how the energy efficiency of a house can be modeled by a simple machine learning technique. Houses come in different shapes. Some are tall, some are low, with big or small windows. Some shapes are more energy efficient than others. Take a hot summer day with sun rays beating up everything and no cloud in sight. A house with a large roof will heat up. Windows contribute with their greenhouse effect. The same effects are mitigated if less surface is exposed. Keeping a house cool will require more or less energy, and some shapes are more efficient in keeping out the heat, or, which is the same, keeping the cold inside. The opposite happens in winter, when we want to keep as much heat as possible inside the house, with heat flowing the opposite way from the roof. The effect is even worse because hot air tends to move up. But the bottom line is the same. We need energy, and energy costs money. Is there a chance to predict the energy efficiency of a house, maybe even before we build it? We can take lots of measurements on the house's blueprints, but relating the physical features of a house to heat dissipation and buildup, and ultimately to energy efficiency, is far from being an easy task. Here is where machine learning comes in. Let's take many existing buildings, measure them, and put them into a table, one row per building. Most measurements are related to the design of the house: width, height, roof shape, materials. Let's call them the inputs, because they are the variables that we control. Other columns are the outputs, that is, the quantities that we want to predict: heating load in winter, cooling load in summer. To build a model that relates input and output quantities, and that will help us predict the efficiency of new buildings, let's import the table. As described in the book, let's randomly split the samples into two sets, one large for training and one smaller to validate the method. Now let's take the k-nearest neighbors model factory and connect it to the training set. Let's select the inputs and output attributes among the table columns and generate the model. K-nearest neighbors is a lazy learning model, so learning takes little time. Let's see how the model's predictions match the measured outputs from the validation table. To do this, we create a bubble chart that compares the measured and the predicted outcome. As we can see, even though the prediction method is very simple, there is a good matching between prediction and reality. We can also use the model to plot the energy efficiency of a building against the input parameter. Just create an output sweeper on the model and sweep all parameter values to see how the outcome changes, with colors representing different predicted power consumptions for different values of the input variables.